Hello and welcome to Identirati Office Hours. I'm your host, Mike Schwartz, founder of Glue, and today is episode 88. Our topic today is Rethink Authorization, Immutable, Versionable Auth Models for Trusted Delegation. Our guests today are Nicola Gallo, co-founder and CTO of Nitro Agility, and our co-guest is Antonio Redesca, a co-founder and CTO of Nitro Agility. Welcome, guys.
Hello, Mike. Thank you very much for the opportunity.
Hi, Mike. Thank you for having us today.
Cool. Are you both CTO, Nicola?
Nitro Agility is composed by two divisions. We have an Italian and a Moldovan division. So as we are working on different matters, and we are a small company, we have both the title of CTO, even though it's not proper correct.
Interesting. Okay. Well, actually, before we start, just a little bit of housekeeping. I want to ask everybody to go to the Identirati Office Hours page on LinkedIn and just hit follow. We're trying to break 1,000 followers. Please help us get there. And before we dive in, I wanted to ask the guests for their background. So Antonio, let's start with you. Tell us a little bit about your background and how you got here.
Okay, so I'm basically a software developer because I continue to like to write code from more than 25 years. And after that, I was studying, I started to work in several companies, especially in banking. And in my career, I was traveling around the world, working as consultant for a lot of projects. Basically, as every Italian, Cristoforo Colombo, as the Italian Cristoforo Colombo. And exactly during this time, I was learning about one of the first microservices architecture in Europe was done together by me and other people in a huge bank in Netherlands. And in this time, I was with Nicola building this company, Nitro Agility. We started in 2019, but we know each other from 20 years, something like this. And that start was, let's say, we were focusing much more on consultancy, develop a project for customer. But from a couple of years, we understood that we can take our background and try to create something that basically doesn't exist in the world of the authorization. This is the idea. But everything, as I said during our talks, born and come from our experiences. Okay, we are people that worked on project. We understood what we miss the industry. We try to do something that is going to be, let's hope, interesting and useful for everyone in the world of the authorization.
And Nicola, what was your journey like?
Yeah, so I am a co-founder of Nitro Agility. I spent most of my time working in England, building software mainly in investment banks, all American investment banks from JP Morgan, Citigroup. I started working at the beginning of my career. I started working mainly on front end. Then I started moving on the back end, and then finally I started working on distributed systems. So distributed systems are the type of system that I like the most. That they are the main point of my passion. As Antonio said, we decided to co-found Nitro Agility, and at that time the industry was moving on the microservice architecture on cloud native pattern. So we start consulting for many clients, and we start building many solutions for all of them. Building all these solutions, we understood that there are some limits, there are things that has to change. And in this context, we decided to start looking more in detail into the authorization stack. And we start building what is today an open source project, which is PermGuard. And that's it. So it happened that we are working in the authorization space, in the identity, even though our background is on software development, software architecture.
So I'm going to jump ahead a little bit and ask you, Antonio, how does I wouldn't be a proper live stream guest if I didn't, or host, if I didn't ask about AI. How has large language models intersected with authorization and also with risk management?
There is a lot of intersections, in my opinion. I will consider two type of intersection. The first one is how the LLM can help the authorization. For example, in our project in PermGuard, we are using LLM to evaluate, for example, the vulnerability of a policy. You know, the LLM is great when you need to find the vulnerabilities and test if a piece of code could be injected or not. We identified, but this I will speak about later, another type of risk that could be a revenue risk and something like this. But the other, in my opinion, opportunity is how the authorization can help the LLM. For example, one of the points that, in my opinion, at the moment is really, really underestimated is the fact that we give to the LLM a lot of information, especially calling public APIs. Okay, are we sure that those information should really arrive to the LLM? Are we sure that this person could give data to an LLM? So this is, in my opinion, 2 points. Use the LLM to improve the authorization, but use the authorization to manage the LLM. And on this, in my opinion, we have a white paper. There is nothing. And I think that the industry is going to work on this because there are a lot of data that are coming in the LLM and should not be there. One of the biggest, let me say, point that I listened is this LLM should not have those information because are private and so on. So
Right.
I think that the intersection is very big and is on both sides.
Now, thank you, Antonio. So Nicola, we actually, I think, connected in the Cedar community. Before we dive into the actual topic of the episode, I know we're digressing a little bit, but maybe we could just indulge me and talk a little bit about why you chose Cedar as a policy syntax, and also, are you using the Rust engine or the Go engine from Cedar also, in addition to adopting the Cedar syntax?
Yeah, I mean, in terms of our open source solution, the focus is not on the language. We adopted the Cedar language. We are testing it. Currently, we are using the Go version, but as it is written, the engine, we can change also to Rust that part. Because, I mean, one thing to notice is that currently the Go language version of Cedar is not that complete. In terms of languages, we can use many of them. In fact, we are planning also to integrate the Rego language. So our solution is based more on the approach on the server, all the environment that are required for the authorization, but we abstract from the language. So we decided to use a Cedar language because we think for application is better suited compared to Rego. It's more easy, it's more close to what the company they're gonna need. Whilst Rego, I do feel is more close to people that are building authorization for infrastructure. That's why we started with Cedar.
I see. So Antonio, I'm pivoting back to the LLM. What authorization data do you feed into the LLM? Do you feed the decision logs? Do you feed the policies? I understand that you also want to filter data maybe based upon policies, but in terms of data that's coming out of the authorization infrastructure, what's interesting to you?
Okay, as you can imagine, now we are work in progress on this. There is a lot of to do. Okay. At the moment, we are feeding with the policies and we are working on, as you said now with Nicola, with Cedar. Okay, we try also now we are even thinking to create an intermediate domain-specific language to avoid the difference when we are going to introduce Rego. By the way, at the moment we are analyzing the policies to evaluate the risk, the vulnerabilities, and some other stuff on this side. By the way, we are going now to, it's going to be something, everything is work in progress, because today we were discussing with Nicole how it's going to work the integration with the events. In future, we are planning to integrate some threat analysis tool. So it's not just about the LLM.
Okay. Well, I think it's time to finally get to the official topic. Nicola, maybe you can just start by talking about what is AuthZ star.
Yeah. So before to talk about ZTAuth star, I think it's worth to understand how we got there, because that's something that happened because of our reason. As we said before, we are building a software solution for clients. Whilst we are building all this solution, many times we've been facing the same problems. And we start realizing that there are some common patterns that are shared across different industry, different clients, different type of application. Okay, there is one that stands out, which is especially tied to distributed systems. So let's take an example. For instance, a common use case is an application which receives a request via API. This API processes the request in an asynchronous manner, publish the request to a service bus, maybe Apache Kafka, whatever. And in the other end, there is a consumer that is going to process this message, analyze it, and do something. So what is going to do the consumer? It may decide to persist some data in the database, may decide to republish the message, or in alternative, may decide to call another API. So when we start building our solution, we mainly focused on this scenario. So here there are few important points. So first of all, when we pick a message from an Apache Kafka queue, we don't have a JWT token. So at this stage, the consumer is going to read the message, is going to say, look, I received a message, I trust the message, then we're going to see how and if I can trust the message. And now I'm going to do something. Okay, if I'm going to do this on my application, but what if I have to call an external API? Which JWT token am I going to use? That's the problem. So based on this example, we start building all the concept, and then we finally arrived to the ZTAuth star. One important thing to understand is that an authorization model, the way we see, needs authentication. So the authentication is important. However, it's not always guaranteed to have an authentication token. So for instance, if you get in Europe, we have all the EU wallet. We start using the registered electronic email. We have certified documents. So let's take another example. So if we take, for instance, the use case of an API which receives a message, which receive a request and publish on Apache Kafka, this is very specific. But let's take another example. Let's suppose you send a certified email and you have a consumer which is going to fetch the mail from this certified provider and is going to process it. At this stage, still you don't have an authentication token. So this let us understand that there is something that has to change. And in order to solve this, we start looking in solution like Spiffy, because Spiffy is very relevant also in the work we are doing. And we start approaching this in a different way. Just to make clear, we don't want to replace the authentication stack. So this is a solution that is going to work along the authentication stack, the OpenID stack, the Auth stack. However, there are some use cases that must be implemented in a different way. Okay, so ZTAuth star stands for zero trust, which is a well-known concept, and Auth star. So Auth star is a name that we decided to pick because our solution revolves around models. They can be authentication model and authorization model. On the top of this, we've got also a layer of trust that we introduced that allow us to specify what are trusted elevation and trusted delegation, because also the delegation is another hot topic that in the industry that has been not fully covered. And with this approach, we have been able to start approaching this type of problem, and we found a solution that by today we can see is proving to work.
Antonio, I'd like to ask you actually the same question. How is, or slightly different question, how is ZTAuth star different from what's out there today?
In my opinion, it's very different because it's essentially is a specification that try to cover everything, and there's a lot of interesting stuff. For example, the first thing is that every authorization context is immutable. Okay, is immutable and versionable. And this is extremely important. As we said before, the other point is that when we are going to combine, for example, machine learning and all the authorization process, and we would like to change the permission, we really don't change the permission, okay? As I said, our authorization contexts are immutable. In the specification is written, is described the possibility to use set operations to combine with different authorization contexts. So I give you a practical example. Imagine that you have an authorization. Okay, this authorization gives full access to the system. There is another system based maybe on machine learning that is going to say, okay, there is something that doesn't look good. What we do? Essentially, this could generate a new authorization context that could be combined with the original one and generate a new authorization context that essentially is going to, for example, block some operation to this person that probably is not the guy that should do something like this. The other thing is that is described in the specification is the possibility of attach annotations to authorization context. For example, could be the risk on this policy. Okay, so if I have a huge risk combined with some other information, I could apply the same set operations. Okay, so this is in my opinion are very, very interesting stuff. Of course, I don't have all time to describe everything in the specification. Specification is quite long and, in my opinion, exhaustive. But another thing I want to say.
I just want to hit pause for 1 second.
Can I answer to a question that I see in the list? Because a person
let's actually address the questions later on LinkedIn.
Okay.
Because we'll have all the time in the world to do that later. Sorry, audience. And I tend to listen to the guests and not read the chat. If I read the chat, I get distracted.
I'm gonna call
I don't listen to what you said. But I wanted to hit pause because I think something you said was really interesting. And I did post a chat message about this, which is that you said the use of set operations, like SET, sets, set A minus set B equals, and this other set, or the intersection of sets. And set operations are really powerful. They're like magic in computer science.
Are really powerful and
so
simple, because the point is that everyone knows what is a set operation, okay? So we sometimes, I read articles, I think that I'm not so smart guy, so I read some articles and I find them quite complex. But the ideas that are really effective sometimes are really the most simple, and the operation set is something that we learn at school.
Literally learned it in kindergarten.
Yeah.
I'd like to put up a picture now because we did prepare actually a slide for this, and I'd like Nicola perhaps walk us through. I've been, and one thing that I found very interesting is that I'm used to that principal, action, resource, context. And I looked at this request, and what I realized is that you have principal, action, resource, context, but you have this extra thing in here called the subject. I'd like to actually ask you to explain sort of this. Why did you feel the need to add in, to extend the park syntax and add another element here?
Okay, so first of all, the difference between principal and subject. The principal is the identity which has been authenticated, whilst the subject is the final subject we are trying to understand if it can do something or not. So let's have a look into this example. Let's suppose there is a service, an application, which would allow to send some request, not via API, but via a registered email. So we have, in this example, we have an email from Luca Verdi, okay? Luca Verdi, what is going to do? Is going to send a registered email, which has a legal value. So once you receive this email, you have legal value. And in this email, what is going to do Luca Verdi? Is going to send a request on the behalf of what we named Mario Rossi in this example, and is going to ask to complete an action. So what is going to happen? So there will be, first of all, the workload. The workload is going to be connected with the email provider. It's going to read the email and is going to ask the policy decision point if this operation can be trusted, can be executed. So how is going to work in this case? So first of all, the workload has to be authenticated. So in this scenario, you can have a tool like Spiffy, which is going to create an identity for the workload.
Right. Or OAuth.
Yeah. And
OAuth, yeah.
Yeah. In this case, the principal is the identity of the workload, not the original identity which made the request. Okay. So,
absolutely. Yeah. I mean, I think that this is a point that I'm always making, is that people don't speak TCP/IP. Like, we need some type of piece of software that actually connects to the digital world, and we call that piece of software the workloads. And normally there's a hornet's nest of workloads swarming around us humans that are doing various things and even talking with each other, including AI agents. But go on. So I like this example. A person sends an email, it's received by a workload, the workload has to do something with it, and so it says, am I authorized to do this thing?
Yeah, and you're going to do on the behalf of the original identity. But in this case, what is going to happen? So you have a subject. Let's ignore for now the structure of this subject. I'm going to explain why there is a name which is citizen submitter actor. So the workload is going to ask the policy decision point and say, I've got a request for this identity. I want to make sure this identity is entitled to execute this operation. They can submit on a certain document. When the workload is going to ask this to the PDP, is going to send in the request and say, the request is made by the workload ID. And maybe I'm going to attach also a JWT token, which is the JWT token of the workload. Is going to state that the target identity of this check is Mario Rossi, and this operation was made by Luca Verdi thanks to a delegation. Okay, why we need this? Because in this case we have the whole context. If you can move to the second page.
Okay, let's attempt. I'm terrible at screen sharing, but I'm going to give it a shot. So this is a lot of words and details for a slide, and I apologize to the audience if you're looking on your phone. But actually, I have a note here. Every Identity office hours has a wiki page. If this one, the link for this one is glue.co/IOH-88. So if you can't see this on your phone, I'm going to post this on the wiki, and you could check it out after the episode is over. Sorry, Nicola, go ahead.
Yeah. So what is going to happen under the hood? So the main point is, first of all, we are onboarding zero trust. So we're going to be adherent to all the zero trust principle. Second, we are going to work with this authorization context. Before we said ZTAuth star stands for zero trust and Auth star model. We have two types of models, Auth N model. So they are models which have all the metadata which come from the identity provider and can be fed to the authorization server, maybe via policy information point. And then we have the authorization, the AuthZ model. The AuthZ model, we didn't say before, what it is a model which includes all the information that are needed to resolve an authorization request. So inside to an AuthZ model, we are going to have the policies, and we are going to have also some trusted statements. So this is something new that we are introducing with this approach. You have policy. In our case, we have the Cedar policies. Then we've got other type of statement which allow us to state a certain operation can be done. So now let's look at what is going to happen under the hood. The authorization, the policy decision point is going to receive the previous authorization request. The ZTAuth star compliance server, what is going to do? It's going to say, okay, first of all, I want to check if this operation can be executed. How is going to do it? It's going to load an authorization context, which is going to include all the policies that are attached to the identity, to the principal making the request. So in this case, it's the workload. When it's going to create this authorization context, which is made from the authorization model, is going to have all the permissions. So what is going to happen? It's going to say, okay, my final check is to verify if, first of all, Luca Verdi can elevate to the Mario Rossi context because he's acting on the behalf of Mario Rossi context, and if he actually received a delegation from Mario Rossi. So what is going to happen is this. So we are going to create a new authorization context for the workload. So in this case, we are going to elevate to a new context, which include what? All the authorization model for Luca Verdi. So we're going to say Luca Verdi. This is the Luca Verdi authorization context. Okay. The final check that we want to do is not to check if Luca Verdi can submit a document, but we want to check if Luca Verdi can elevate to Mario Rossi. So in this case, what is going to happen? As we have a trusted statement where we can see that Luca Verdi can both elevate and is delegated by Mario Rossi, we are going to create a new authorization context which contain what? All the policy and the trusted statement for Mario Rossi. So what is going to be the outcome? We are going to have an authorization context which include all the information of Mario Rossi and is going to be used to evaluate the authorization request to see if Mario Rossi can actually execute this operation or not. So in this way, what we have authorization context that are actually immutable because we gave also some feature to this authorization context. The authorization context have to be immutable and versionable. And on the top of this, you have to be able to transfer them. So why this is important?
Let me hit a pause there. I'd actually like to let me stop the screen sharing and give Antonio a second to respond. Antonio, if you could pick up on what Nicola was saying about why do you need some GitHub-like revision control in the system, and which documents are getting this revision control? Is it the policies themselves? And what is actually needs revision control in this level of management?
Consider that this is code. Basically, a policy is code and need, of course, some versioning and some control. If you give a look to PermGuard, okay, PermGuard has a lot of PermGuard is solution that we are building around the ZTAuth specification. As all features, it's quite similar to Git in a lot of stuff. Okay, Nicola can even explain better this because he was working on this engine. But the versioning is extremely important. And for example, just to return to the machine learning part, we made already an integration that is able to catch all those data from the PermGuard database about all changes that we made to the policies, and for example, switch the vulnerability risk and so on. So we have integrated, we use the immutability and the versioning to integrate also the machine learning features. Okay, so for us it's extremely important. In our, before to work on PermGuard, we basically, or maybe probably Nicola, all systems that we made in last year were event-based, yes? And we took this approach to this, let me say, to PermGuard, okay? Where we have events, we have versions, we have data. So this is why, from where come this? Nicola, do you want to say something else?
So there are many reasons why we need a version storage. So first of all, we've been developing what we named to be the NoTP protocol, which is the negotiated object transfer protocol. So why we cannot use Git? So first of all, here there is a difference from our approach and what we can see other companies are doing. When you build your policy, the idea is not to have your policy in your source code, build it, pack it, and ship it in production. But instead, the policy, they have to have a storage that is a Git-like storage that can be built during the development time. But once you start living in the production environment, you should start enhancing this object storage. Likewise, you did in the development side. So let me give you an example. All the other companies, so what they are doing is say, look, I'm coding the policy. So for me, the policy is a source code that is going to be under Git version contract. But what is the problem? So let's suppose you want to build a cloud stack. So the YAM for a cloud stack. So let's take as an example the AWS Identity Access Management. When you go in AWS and you define your YAM policies, or the same on Google, Edge, or whatever, you are saving this JSON, this policy in the console, and from that point in time, they're going to be applicable in all the environments, okay? So they are not going to go on a Git version control that is going to be built, packaged, and released. So that's proper real-time data. So that's your policy. So the same approach is used by us in PermGuard, but what you are saying, where are we going to store this policy? So we start building object storage that is like Git, is used under the hood, the same principle algorithms that are very similar to Git, but they are optimized for the policy management. I don't know if it makes sense. So we are building, you can see like it is a special Git that we build, optimized for the policy.
So essentially, we are really centralizing the policy management. Okay, so we have a central place where we have the policies. But the interesting part is that also the applications work in an eventual consistent way. Okay, the idea why sometimes we forget, Nicola, to speak about this, but essentially the eventual consistency, in my opinion, is the most important thing that we need in modern architecture. It's not just to call complex system is not just to call an API, okay? And as Nicola said, also, we cannot have the policy in the code, okay? We need a place where will be the policy. But your question could be, but if the central storage is off, the system is not going to work. No, it's going to work because we have an eventual consistent architecture where the agent take the policies, the last version, take internally, and could survive even to a full down of the central database. Okay,
Mm.
so this is another point that is not connected to specification. This is how is built the PermGuard. And I repeat, all those stuff are coming with the experience. Okay, complex architecture are by design fully eventual consistent and asynchronous. Okay.
I have a question, Nicola. It just occurred to me sort of on the fly, but is PermGuard meant to be embedded in the browser or in a mobile app, or is it PermGuard meant to run, the PDP meant to run in the cloud?
I mean, there is the part of the work we are focusing now is all the infrastructure for the authorization server. Then what is going to happen? This decision might happen on a policy decision point, which is running at the server, but of course can also run close to the application which is making the decision, because there is another aspect. When you are going to make the decision, the decision on authorization has to be fast. So you cannot expect to go through the wire every time you're going to make a decision. So you have to make some decisions that are close to you. So here comes the idea of proximity policy, PDP. The idea of a PDP is to create a PDP which is detached from the central server and is going to run close to you. At this stage, we are building proximity PDP to run close to the IoT, smart home, proximity node on Kubernetes and so on. In future, we are going to build also one for the web browser. We didn't implement yet, but we can do. Just to answer to your question, to make it more clear, let me take another example. Let's suppose I need to use PermGuard in a smart home. So image, you have your smart home, you have your door, and you have
my home is so old, it's just hard for me to imagine it being old. I mean, you can see it back there.
Yeah, but it's still not fully answered. So let's suppose I get in front of the door, okay, and the door has to decide if I can get in the house or not, okay? At this point, there is a problem. Maybe the door is connected to my internal network, and I am connected via mobile on my mobile network. What's going to happen? If I lose connectivity inside the flat, inside my house, the door is going to lose the connectivity. So how might a solution like PermGuard work in this case? So first of all, the door is going to synchronize all the authentication and authorization models. So that's why they need to be transferable. They have to be immutable and versionable. Why? Because when you pull all this metadata, all this information, all the policy, the trusted layer, you are going to copy all of this on your local hardware, which is the door. And then what is going to happen is that there is a proximity node, which is a proximity PDP, which is going to be in charge to answer to your question. Why you need to be immutable and versionable? Because we are also following the zero trust principle. So first of all, if anything happens, you have to be able to prove that you actually executed that authorization request against the policy decision point. You have to be able to make sure that there is an history, you can review all of it, and you can execute it locally. So this is the same use case that you would have on a sidecar pattern in Kubernetes. So imagine you have your application distributed on a Kubernetes cluster. You're going to have all your pod application that are going to synchronize all the authentication authorization model close to them, and they are going to make the decision. Then in our specification, we are also starting to define how we can make sure we can prove the data actually didn't change. Because let's suppose you have the policy. When you are going to make the decision, you are going, maybe in the authorization request, you are going to load all the data from the server. You're going to make the decision. You're going to sign and prove that decision was made on a specific version of the object storage. and you're going to return the answer. What is going to happen that whoever received this answer can store this information and prove that this authorization request was executed. The policy decision point doesn't have any way locally to change this because there is a concept of immutability and versionability. I don't know if I answered to your question.
Yeah, no, it's quite interesting. I was laughing because you said the network to my door, and I was thinking my door doesn't even have power. And I was thinking about the actual key that we have, which is a pretty pedestrian house key. So, well, let's actually switch to last thoughts. We didn't get to talk about the confused deputy problem, or maybe we did, but Antonio, let's start with last thoughts for you. I mean, we could talk for hours. What do you want the guests to take away from this, the audience?
Yeah, for let's say that for us it was extremely important to explain a bit our ideas, okay? And in terms of the ZTAuth star specification, that is a different way to think about the authorization. Okay, I don't want to say that it's the correct way. It's a different way. After anyone can take it as correct or not, it's not a problem for us. But we try to give to the people our idea, and in my opinion, it's not so bad. On the other side, as we said now, we are trying also to promote PermGuard, that is a solution that try to implement all this specification. And we're focusing now on those features exactly to express the power of this solution in terms of eventual consistency, in terms of central policy governance and stuff like this. About what I do about integration with, I'm not an AI guy, by the way. I'm an integrator, and what we are doing is to integrate with, of course, with the help of experts, LLM, machine learning, and stuff like this. And this specification born exactly to try to make this integration the best possible. Okay, so I think that this was a great opportunity to discuss those arguments and to give to the people another view of the authorization problem that is not something very simple, because just to answer to one question, I don't see around so much. There are standards about authentication, but about authorization, there is not so much. So this is these are my thoughts.
Check out PermGuard. Nicola, last thoughts?
Yeah, I mean, as Antonio said, all the world of the authorization is vast and it is still unexplored. So our attempt on ZTAuth Star is to start pointing out there are many aspects we can see the industry still not addressing. We are trying to address all of them. Our hope is to see if this work we are doing can be somehow shared with other companies, with other experts, understand that we can keep evolving it and start building a different stack for authorization. As ideally, we would like also to start working on this in some sort of proper solid specification. And finally, of course, if you are interested into this work, maybe the first thing you can do is to start playing with PermGuard.
Cool. Yeah.
Just Mike, I want to answer to last thing. I will never buy a house with only electronic doors.
Yeah. Right. That was a final show of confidence in our current state of technology. Okay, cool. Well, I just wanted to say thank you to the audience for hanging in there. Apologies to the audience for not taking the questions, but I do go back and I answer all the questions that come on LinkedIn. YouTube, watch out. The Restream bot sometimes deletes the YouTube messages. So if you want to post, please post on LinkedIn. And I do I do answer all the questions. And just announcing the next episode real quick, we're going to talk about a tangential a topic, detecting and correcting API drift. with engineers from the company called API Context. It's a really interesting topic about how APIs evolve, and you need to really keep track of like what the delta is on these APIs, maybe how to secure them incrementally. With that, I'll thank the guests and thank the audience, and see you next time.
Thank you very much.